Okay, number 7. Since of 50 people surveyed, 18 preferred rock, 12 preferred rap, 5 preferred classical, and 15 preferred music in a miscellaneous categories. If a store owner ordered 500 CDs, how many of those would have to be rock? So the first thing you need to do is you want to put your rock over the total. When in the survey that we did in the beginning, there was 18 rock over 50. For me to find the overall for the 500 CDs, I'm going to put my 500 on the bottom because that was the total, and X on top. So now, let's cross multiply. So 18 times 500 is equal to 50 times X. Multiply this, so you get 9,000 is equal to 50X. You need to divide by 50, and you get 180 is equal to X. So your answer here would have been C. Number 8. At a car wash, 3 options are available: regular, super, and deluxe. Out of 20 customers, 12 chose the deluxe option. If 400 customers used a car wash, how many of those would be deluxe? So the first thing I want to do is put deluxe over the car wash. And so now I have 12 out of 20. And I want to know how many if there was 200 customers. So at this point now I need to cross multiply. I'm sorry, that was 400 customers. 400. So when I cross multiply, I'm going to do 12 times 400 is equal to 20 times X. This is 4,800. When I divide by 20, X is equal to 240. So 240, which is D, is my answer for the number 8. Number 9. It says the table shows the types of trays and drink selections at the cafeteria on Friday. There's 3 types of trays, which are pizza, chef salad, and chicken sandwich. There's 4 drinks, which are milk, bottled water, juice, and chocolate milk. Sean will randomly select 1 tray and 1 drink from these choices. What is the probability Sean will select a salad and a bottle of water? Well, the first thing you need to do is find out how many combinations you have. And you're going to do that by telling me the number of trays that he has times by the number of drinks. So there were 3 types of trays, and there were 4 types of drinks. So when I multiply, I have 12 combinations. Now, the only combination that he can get a salad and a bottled water was 1. So it would be 1 over 12, which is A. That was number 9. Number 10. Which number would make the sentence correct if you numbered this from smallest to largest? My first one is a fraction of 3 over 11. The second one was 1.34. My choices were 1.5, 0.27, 35%, or D, 1.2 times 10 to the 1. I need to change this to a decimal first, so I'm going to hit 3 divided by 11. That will give me 0.27, and it repeats, so I'm just going to round. I'm going to change 1.5 to a decimal. This is already a decimal, so we're going to keep it the same. 35% goes to 0.35 because we move it 2 places to the left. And we have 1.2 times 10 to the 1. 10 to the first power is 10, so that's 1.2 times 10, so that gives me 12. So now, 0.273, we look at 0.27, but if I go to the third decimal place, that's a 0. This is smaller than the 0.3. So the only answer that could be between 0.273 and 1.34 is 0.35. So my answer would be C. Number 11. The original price of a table is $650. The store discounted the price 25%. What is the exact price of the table, not including tax, with the discount? So you need to take your price of your table. You're going to times it by your percent as a decimal. When I do that, you get $162.50. Now this is the amount of the discount. So now I want to find out what the price is after the discount. So I'm going to take 650 and subtract 162.50. So I get 487.50. That answer is B. Number 12 says Taylor walked 3 miles on Monday. 1 mile is equal to 5,280 feet. Which proportion can be used to determine how many feet Taylor walked on Monday? So I'm comparing feet to miles. I'm sorry, let's change that. Let's do miles to feet. Now, it said in the second sentence, 1 mile is equal to 5,280 feet. So that's one fraction. And then the question was, she walked 3 miles on Monday. How many feet would that be? So we're going to put our 3 miles here. And that would leave us with X on the bottom for our feet. So when we look at our inequalities, A is the correct inequality for that. (13) Josie experimented with tossing a colored cube 60 times. The table below shows the frequency of each color face up. The question is, what is the experimental probability of rolling a blue? So I want blue over total. So when I find the blue, that was 12, and she rolled the dice 60 times. And now I need to reduce that, and so that would be 1/5, because 12 will go into both of those. So my answer here would be B. Now 14 says, what is the theoretical probability of rolling a blue? Remember, theoretical is not looking at any experiment. It just says that I have a colored cube with 6 different colors on it. So it would be 1/6, 1, because there's only one blue colored side, and there was 6 total sides of the cube. So that was 1/6, which would have been A. Now 15 says, using Josie's experiment, compare the experimental probability to theoretical. The experiment, remember, was 1/5, and the theoretical was 1/6. Well, if I divide those out, this is 0.2, and 1 divided by 6 is 0.16 repeating. And so my thing would be they are very similar, but the experimental has a higher probability of getting blue over the theoretical in this experiment. Okay, number 16 said answer the questions using the spinner at the right. Show all your work. So I have a spinner over to the right, and it said what's the probability of blue? And it wanted a fraction. So I need to count how many blue over the total. There were 4 blue over a total of 8. I need to reduce that, so it is 1/2. My percent, I'm going to divide 1 divided by 2. I get 0.50. Move it 2 places over, so my percent is 50%. Now I need to find a probability of red. I have 3 red out of 8, so I would put 3 over 8. That one cannot reduce. Now when I divide, I get 0.375. To make it into a percent, move it 2 places, and I get 37.5%. Probability of not white. So this can be any color, just as long as it's not white. I only had 1 white square, so the others would be 7 out of 8. When I divide